The supplement industry pulled in over $177 billion last year. $177 billion spent on capsules, powders, and extracts derived from plants your great-grandmother grew along a back fence she never thought twice about. She didn't buy the capsule. She grew the plant. And the strangest part, modern phytochemical research keeps arriving, study by study, at the same conclusions she already held in her hands every season, that the living root, the fresh leaf, the fermented preparation preserved something that no extraction process has yet fully replicated. Today we're counting down 13 plants that Scripture, ancient healers across multiple civilizations, and peer-reviewed science have independently studied plants that can feed the body, support traditional healing practices, and cost almost nothing to grow once you understand them. Pay close attention to number 1. Most people have access to it right now, in some form, and have never understood what it quietly does at the cellular level. And stay with me to number 7. I want to tell you a story about a man who walked 3 days into the desert without food or water, collapsed under a solitary tree, and woke up to find that what was placed beside him wasn't medicine from a physician. It was food. 2 things. Actually, and the physiological explanation for why that specific combination could have helped restore him is one of the most compelling things I've encountered in any research tradition, ancien or moderne. Number 13. Comfrey. In the medieval European herbal tradition, comfrey held a reputation so precise it bordered on the anatomical Hildegard of Bingen, the 12th century Benedictine abbess, whose Physica remains one of the most systematic medical botanical texts of the pre-modern period, prescribed comfrey root preparations specifically for injuries involving connective tissue ligaments, tendons, the deep tissue beneath bone. She called it wallwarts, and she distinguished between the surface wound and the deeper structural injury with a clarity that reads almost clinical. The Ebers Papyrus, the Egyptian medical compendium, dating to approximately 1550 BCE, contains references to plant preparations used for what translators describe as bone knitting and wound closure. The specific plant identification remains debated by Egyptologists, but the preparation method described, a warm root poultice applied externally, resembles preparations later associated with comfrey in European and Persian traditions. Avicenna's Canon of Medicine, compiled in the 11th century, describes plants used for broken ribs and deep bruising, with root preparations that some botanical historians have compared with comfrey or closely related symphytum species. 3 traditions, separated by centuries and continents, arriving at similar plants and preparations for similar purposes. The compound responsible is allantoin, a nitrogen-containing molecule found in comfrey root, roughly 0.6 to 0.8% by dry weight. Allantoin is associated with cell proliferation and wound healing processes. It can support fibroblast activity, the cells responsible for producing collagen and connective tissue. This isn't merely speculation. Allantoin is a recognized ingredient in some topical skin protectant and wound care products. What traditional healers were observing when they prescribed comfrey for injuries may have involved processes that modern researchers can now examine at the cellular level. The mechanism is cellular. The traditional observation was real, even if the historical explanation was different. Comfrey also contains rosmarinic acid, a phenolic compound studied for anti-inflammatory activity, including in research involving osteoarthritis. A 2004 randomized controlled trial, published in Phytomedicine, found that a comfrey root extract preparation performed better than placebo in reducing pain and swelling associated with ankle sprains, with researchers describing the results as clinically meaningful. External use only. This is critical. Comfrey contains pyrrolizidine alkaloids that can be hepatotoxic when taken internally. The root should not be brewed into a tea for drinking. Traditional and research-supported uses have focused on topical preparations, such as a root poultice, a leaf compress, or an infused oil applied to the skin over an affected area. Prepare it this way. Wash and finely grate fresh comfrey root. Spread the grated root across a clean cloth. Fold it over. And apply it warm, not hot, to the affected area. Leave it for 45 minutes. The grated root will feel slightly slippery, almost gelatinous. That's the mucilage, which contributes to the plant's texture. For a longer-term preparation, some traditional practices infuse dried comfrey root in olive oil for 4 to 6 weeks in a cool, dark location. Then strain. Because of the potential toxicity of pyrrolizidine alkaloids, comfrey preparations should be used cautiously and only as directed by an appropriate health professional. Hildegard didn't have a clinical trial. She had a monastery's worth of patience and decades of careful observation. The research is now beginning to examine precisely what traditional healers recorded. Number 12. Skirret. The Book of Genesis describes the garden as a provisioned place, a space where food grew without the anxiety of scarcity. The Hebrew word used across the garden narratives, gan, denotes an enclosed, cultivated space. Ancient botanical scholars who have studied the plants, likely present in Near Eastern, enclosed gardens of that period, consistently identify root vegetables among the foundational crops, plants that stored energy underground, that could be dug through dry seasons, that asked little from the soil and returned steadily. Skirret, sium cisarum, was a root vegetable that moved through the ancient world with precisely that reputation. Mentioned by the Roman agricultural writer Columella as a prized garden crop, referenced in the Capitulaire de Villas Charlemagne's 9th century estate management document that listed plants to be maintained in royal gardens and grown in English cottage gardens until the 19th century. Skirret held a place in cultivated food culture that spanned more than 1,000 years. Dioscorides, the 1st century Greek physician whose materia medica remained in medical use for centuries, described a root he called scion that grew in cultivated gardens and could be eaten boiled, with a flavor he described as sweet and mild. Botanical historians have associated this description with skirret. Although the identification is not absolutely certain, he noted it as gentle on the stomach, useful for convalescent patients who could tolerate little else. The modern nutritional analysis of skirret is surprisingly compelling. Each root bundle contains inulin, a prebiotic fiber that can feed beneficial gut bacteria, including lactobacillus and bifidobacterium populations. Skirret also provides moderate amounts of potassium and vitamin C, particularly notable because the roots can be harvested in late winter, when most garden produce has long since ended. Here is what most growing guides omit: skirret roots become dramatically sweeter after frost. The cold triggers an enzymatic conversion of stored starches into simple sugars, the same process that sweetens parsnips and Jerusalem artichokes. A root harvested in November can have substantially less sweetness than the same root harvested in January after several hard frosts. Wait for the cold. The plant is transforming its own chemistry for you. Boil the roots briefly, no more than 8 minutes, in lightly salted water and eat them warm, dressed only with a little butter. They taste somewhere between a sweet carrot and a water chestnut, with a slight nuttiness underneath. 1 crown, divided each fall, becomes 2. 2 become 4. Plant skirret once in loose, well-drained soil, and the root vegetable bill for late winter essentially disappears. The garden was always meant to provision. Skirret is a reminder that some of what provisioned ancient civilizations is still there, waiting to be planted again. Number 11. Elderberry. The elderberry appears in historical medical traditions through several different sources. The Sambuca species, widely distributed across Europe, Western Asia, North Africa, and parts of North America, was present in many traditional landscapes. The sori referenced in Genesis 37, the balm the Ishmaelites carried from Gilead toward Egypt, should not, however, be identified definitively as elderberry. The Hebrew sori refers to a balm or aromatic resin, and its botanical identity remains uncertain. The same passage that sends Joseph into Egypt as a slave references a medicinal commodity being traded across ancient trade routes. In the Sahih Bukhari, the Hadith collection documenting the practices and sayings of the Prophet Muhammad, black seed is referenced as a remedy for ailments except death. That reference concerns black seed, not elderberry, and should not be presented as evidence that elderberry was part of that specific remedy tradition. Elderflowers and elderberries nevertheless appear in European and other traditional medical practices, particularly in preparations associated with respiratory complaints. What is well documented? The Ebers Papyrus, dating to around 1550 BCE, contains a plant remedy that some scholars have identified as elder. The text includes preparations associated with urinary complaints. Although translating ancient Egyptian plant names into modern botanical species is often uncertain, the identification therefore remains a scholarly interpretation rather than a certainty. Elderberries contain anthocyanins, the class of flavonoid pigments responsible for their deep purple-black color, at concentrations that can be substantial compared with many commonly grown fruits. Anthocyanins have antioxidant activity, and elderberry has been studied for possible effects on cold and flu symptoms. A 2016 randomized N-tation, double-blind, placebo-controlled trial published in Nutrients found that elderberry supplementation reduced the duration and severity of cold symptoms in air travelers. Although broader evidence remains limited, researchers describe the results as encouraging and deserving further investigation. Elderberries should not be eaten raw in large amounts, because raw or improperly prepared elderberries can contain compounds that cause nausea and other adverse effects. Traditional preparations generally involve cooking the berries. Higher temperatures can affect some anthocyanins. So preparation involves a balance between safety and preservation of compounds. If preparing elderberry products at home, follow a reliable food safety method rather than treating the berries as a raw food. One mature elderberry shrub can produce substantial quantities of berries annually under good growing conditions. Plant 3, and you may have a recurring harvest every year. Number 10. Cowpeas. The prophet Daniel made a choice that confused his handlers. In the first chapter of the book of Daniel, brought to Babylon and offered the king's food, rich meat, vine, the provisions of empire, Daniel requested instead zeroah and water. The Hebrew word zeroah is typically translated as vegetables or plant foods, and scholars debate its precise agricultural meaning. Pulse crops, such as lentils and peas, fit the broader context of ancient Near Eastern diets. 10 days on plant foods and water. At the end of those 10 days, the text notes, Daniel and his companions appeared healthier and better nourished than those who had eaten from the royal table. This is not a theological argument. It is an observation that a trained ancient observer recorded a perceived health outcome from a plant-based diet over a short trial period. Modern nutritional science has spent considerable effort understanding why such a diet might support health. The Karaka Samhita, the foundational Ayurvedic medical text, compiled over centuries, and reaching its current form around the 4th century, CE categorizes pulse crops as foods appropriate in various dietary contexts. The text describes their relationship to what it calls Agni digestive fire, while also discussing differences among individual pulses. Modern translation legumes can provide substantial protein, fiber, vitamins, and minerals. Although their nutritional effects depend on the specific crop and preparation, cowpeas, vigna, unguiculata, encompassing black-eyed peas, Crowder peas, pink-eye purple hull, and dozens of heirloom varieties fix atmospheric nitrogen through their root nodules. University extension guidance commonly places nitrogen fixation by legumes in the range of roughly 80 to 150 pounds per acre under suitable conditions. They are, in the most literal sense, pulling fertilizer from the sky. But what makes cowpeas remarkable from a nutritional standpoint is their amino acid profile. Unlike many plant proteins, cowpeas provide meaningful quantities of lysine, an amino acid that can be limited in some grain-heavy plant-based diets. Here is the preparation detail. Most sources omit dried cowpeas, contain phytic acid, which can bind to zinc, iron, and magnesium, and reduce their absorption. Soaking dried peas for several hours and discarding the soaking water before cooking can reduce some anti-nutritional compounds. Although the exact reduction varies with the method, adding kombu seaweed to cooking water is a traditional technique in some East Asian cuisines, but claims that it specifically and reliably improves mineral bioavailability should be treated cautiously. Daniel chose plant foods. He chose well. The research suggests that his basic dietary principle can make nutritional sense even if the historical text does not provide a modern nutritional explanation. Number 9. Salsify. Salsify appears in discussions of historic European kitchen gardens and has been associated with the Capitulare de Villis, the Carolingian imperial gardening document, traditionally dated to approximately 795 CE, although the identification of individual plant names in the document is not always certain. It was not a luxury crop. It was a provisioning crop. Something kept growing because it fed people reliably through the season when little else was available. The Benchao Gongmu, the Chinese Materia Medica, compiled by Li Shizhen in 1596, representing one of the most comprehensive botanical medical texts of the classical Chinese tradition, describes numerous roots and medicinal plants. Specific claims that its descriptions refer to modern salsify are uncertain, so the connection should not be treated as established botanical identification. Salsify roots contain inulin, the same prebiotic fiber found in skirret and related chicory family roots. Inulin can be fermented by gut microorganisms and may increase populations of certain beneficial bacteria. Research from institutions, including the Weizmann Institute of Science, has helped establish how strongly diet can influence the gut microbiome. Although individual responses vary considerably, what is less commonly discussed, salsify also contains potassium and vitamin B6, a cofactor involved in numerous metabolic processes, including neurotransmitter synthesis. A 100-gram serving of cooked salsify root provides a meaningful amount of vitamin B6, although the exact percentage of daily intake depends on the nutritional database and serving preparation used. The preparation is simple, but requires patience. Scrub the roots. They will be earthy and slightly sticky, with a latex-like sap that can stain your hands temporarily. Peel them under running water, and drop them immediately into water, with a squeeze of lemon to prevent browning. Boil in salted water for 15 to 20 minutes until tender. The flavor is mild and faintly sweet, with an almost brothy depth that has led to the common name oyster plant. Historic European cooks valued it as a root vegetable. Your kitchen can serve it this winter. Number 8. Crimson clover. Ezekiel 4, verse 9, is one of the most nutritionally interesting food specifications in ancient literature. The Lord instructs the prophet to take wheat, barley, beans, lentils, millet, and spelt 6 distinct grain and legume species, and combine them into a bread. Modern nutritional analysis suggests that amino acids in legume proteins can complement those in grain proteins, improving the overall amino acid balance of the meal. Ezekiel bread, as it is now commercially marketed, draws directly on this ancient formulation. Although modern products and the biblical preparation are not identical, the principle embedded in that formulation, that legumes and grains belong together in a cultivated system, is one that soil scientists have been rediscovering for the past several decades. Leguminous cover crops do not merely add nitrogen to soil. They can also influence soil structure, organic matter, microbial communities, and nutrient cycling. The Karaka Samhita describes agricultural and medicinal practices involving soil preparation and plant cultivation. However, directly equating its descriptions with the modern agricultural practice of cover cropping would be an interpretation rather than a literal translation. The broader principle that cultivation practices can influence the quality of soil and subsequent crops is consistent with modern soil science. Crimson clover, hairy vetch, and Austrian winter pea, 3 widely studied winter cover crops in North American agricultural extension, literature fix atmospheric nitrogen through rhizobium and related nitrogen-fixing bacteria living in their root nodules. Oregon State University Extension places the potential nitrogen contribution of legume cover crops, terminated at early bloom, in the range of roughly 100 to 150 pounds per acre under favorable conditions. But another important benefit is their interaction with soil microbial communities, including mycorrhizal fungi. These fungal networks can associate with crop roots and influence nutrient and water uptake. Although claims that they extend effective root reach by exactly 700% should not be treated as a universal measurement, your tomatoes can benefit from a microbial network that began with a cover crop you turned under months earlier. Broadcast crimson clover seed at 4 to 6 pounds per acre on lightly prepared soil in late summer, or simply broadcast it by hand across your garden beds after the summer crops come out. Water once, if the weather is dry. The plants establish quickly. Fix nitrogen through fall and winter, and when turned under in spring, can return accumulated nitrogen and organic matter to the soil your next garden will occupy. This is the agricultural principle that resonates with Ezekiel's combination of grains and legumes, grain and legume, working together, in sequence and in combination. Number 7. The juniper and the angel's cake. And he lay and slept under a juniper tree. And, behold, an angel touched him and said, Arise and eat. And he looked, and behold, there was a cake baked on coals and a cruse of water at his head. And the angel of the Lord came again the second time, and touched him and said, Arise and eat, because the journey is too great for you. And he arose and ate and drank and went in the strength of that meat, 40 days and 40 nights unto Horeb the mount of God. 1 Kings, 19th chapter, verses 5 through 8. Set the scene for a moment. Elijah has just experienced one of the most intense episodes of sustained physiological and psychological stress described in the Hebrew Bible. He literally ran from Jezreel to Beersheba. Modern estimates place that distance at approximately 95 miles. He ran it after a period of extreme exertion in which, according to the text, he had personally killed 450 prophets of Baal. He then sent his servant away and walked an additional day's journey into the wilderness alone, without adequate supplies, in the desert heat of the Negev. The biblical text presents him as exhausted and overwhelmed. What the text describes can be interpreted physiologically as a combination of extreme exertion, energy depletion, fluid loss, electrolyte loss, and acute psychological stress. Glycogen stores can become depleted during prolonged muscular exertion. Sweating can lead to losses of sodium and other electrolytes. Dehydration can impair thermoregulation and physical performance. This is not simply poetry. It is a description of a person in severe exhaustion. Even though the ancient text did not use modern clinical terminology, what was placed beside him? A cake baked on coals, what biblical food historians identify as an uga, a type of flatbread made from grain flour and water, baked directly on heated stones or coals, and a cruse of water. The whole grain yuga would have provided Elijah with readily available carbohydrate, along with the fiber, minerals, and other nutrients naturally present in less refined grain. Whole grains can provide magnesium. Although the exact amount depends on the grain and serving size, the bread's crust would undergo browning reactions during cooking. But this does not mean that the Maillard reaction creates resistant starch. Resistant starch is influenced more strongly by starch type, processing, and cooling. And the water? Not wine, not broth. Water. He was dehydrated. The most fundamental restoration was hydration. The angel didn't bring a feast. The angel brought what the story presents as sufficient for his immediate needs: water and food containing energy and nutrients. He ate. He slept again. He was touched a second time. He ate again. Then he walked for 40 days on the strength of 2 meals. That is presented in the biblical narrative as extraordinary from a physiological perspective. 2 meals alone would not normally be enough to sustain a person for 40 days of walking. So, the passage should not be treated as a modern nutritional experiment. The text itself frames the journey as miraculous. The preparation that most closely mirrors what Elijah may have eaten: combine 1 cup of whole wheat flour with a pinch of salt and enough water to form a firm dough. Press it to about a ½ inch thickness. Heat a cast iron pan or flat stone over medium-high heat until very hot, no oil needed. Place the dough directly on the dry surface. Cook 3 to 4 minutes per side until the exterior is firm and slightly charred in spots. The interior will remain moist. Eat it warm with water. The magnesium and B vitamins naturally present in whole grain flour remain because the grain has not been extensively refined. This is the food that, according to the biblical narrative, helped restore a prophet. Modern nutrition can explain why a combination of water and carbohydrate-rich food would be useful during recovery from exhaustion, even though it cannot explain the miraculous 40-day journey. If this kind of ancient knowledge resonates with you, the intersection of scripture, history, and the science of how food actually works in the body, hit like and subscribe. What's coming in the final half of this list goes even deeper into the plants that scripture mentioned by name and that modern research is only now catching up to. Number 6. Asparagus. Asparagus appears in records from the ancient world with remarkable consistency. The Ebers Papyrus references plant preparations used as diuretics, important in a culture where urinary complaints were documented. Some plant identifications in the papyrus remain debated. So, linking a specific prescription definitively to Asparagus officinalis would be too strong. The Greek physician Dioscorides devoted an entry in his Materia Medica to asparagus root, calling it asparagos, and noting its traditional use for urinary complaints and other conditions. Asparagus was also cultivated in ancient Rome, where Pliny the Elder described methods for growing it. In ancient China, asparagus-related roots were also documented in traditional medicine. Although the species and uses do not always correspond to the modern vegetable, modern phytochemical analysis adds another layer. Asparagus contains steroidal saponins, including compounds studied for biological activity. The shoots also contain asparagine, to the amino acid named after asparagus, and first isolated from its juice in 1806. It plays roles in protein metabolism and other cellular processes. The familiar odor of urine after eating asparagus comes from sulfur-containing compounds, including metabolites derived from asparagusic acid. Not everyone produces or perceives this odor, and genetic variation contributes to the difference. A 2010 study helped document the genetic component involved. The principle consistently honored by ancient sources, yet often violated today, is simple: asparagus should be eaten fresh. Some nutrients and bioactive compounds decline during storage. A spear cut from your own garden and eaten that day can differ nutritionally from one shipped 2,000 miles and refrigerated for a week. Cold slows many biochemical changes, but time still takes its toll. Trench asparagus, crowns 8 inches deep in loose, well-drained soil, enriched with aged compost. Plant in early spring. Do not harvest spears during the first year. Harvest sparingly in the second. From year 3 onward, cut emerging spears until late spring. Then let the ferns develop fully. Through summer, they feed the root crown for the following year's harvest. A healthy crown can produce for 20 to 30 years. Ancient cultures valued asparagus for food and traditional medicine. You can grow it for your table every April, without buying a single bunch. Number 5. Sweet sorghum. The Book of Numbers records a remarkable episode. As the Israelites traveled through the wilderness, they complained to Moses about the foods they had left behind in Egypt: cucumbers, melon, leeks, onions, garlic, and especially the absence of sweetness. Ancient commentators discuss the foods and sweeteners available in Egypt, but there is no strong basis for claiming that sorghum was specifically the missing sweetener described in the biblical passage. Sorghum was nevertheless cultivated in parts of the ancient world, and later became important as a grain and sweet syrup crop. The Sahih Bukhari contains hadith describing the Prophet Muhammad and sweet foods, particularly preparations involving dates and other ingredients. Classical Islamic food historians, including Ibn Sayyar al-Warraq, whose 10th century cookbook is one of the earliest surviving detailed Arabic food texts, describe numerous sweet preparations and syrups. The specific claim that sorghum syrup was widespread throughout the Arabian world during this period should be treated cautiously because historical cultivation and trade varied by region. The Benchao Gangmu extensively documents sorghum or gaoliang. Li Shizhen describes its traditional uses in Chinese medicine and food culture. Chinese traditional medicine associated different grains with different effects on digestion. Although these traditional classifications should not be confused with modern clinical evidence, sorghum syrup also has a nutritional chemistry distinct from refined sugar. It can contain polyphenols and other antioxidant compounds, especially when made from pigmented or less refined sorghum varieties. Because the syrup is pressed from the stalk rather than the grain, some phenolic compounds transfer into the juice. Although the final concentration depends heavily on the variety and processing method. A 2010 analysis in the Journal of Agricultural and Food Chemistry reported substantial antioxidant capacity in sorghum syrup and called for further investigation. The preparation requires precision. Harvest the cane when the seed head has fully browned, usually in late September, across much of the eastern United States. Cut the stalks at the base. Strip the leaves and run them through a mill to extract the pale green juice. Filter it through cloth. Then heat it slowly in a wide, flat pan between 200 and 220 degrees Fahrenheit. Avoid excessive heat, which can degrade some compounds and produce a burnt flavor during the first hour. Skim away the gray-green foam, which contains plant debris and other suspended material. Continue cooking until the syrup reaches the desired concentration. Historical and modern yields vary widely depending on the cultivar, growing conditions, and equipment. So there is no single reliable yield for every acre. Even a backyard patch can produce several quarts under favorable conditions. The sweetness of the ancient world, made in an afternoon. Number 4. Parsnip. The parsnip's journey through historical food traditions is indirect but traceable. The Hebrew word parpisa, found in rabbinical texts from after the biblical period, refers to a cultivated root vegetable. Although identifying it specifically as parsnip is uncertain, Talmudic rabbis described parpisa in dietary contexts, while Dioscorides discussed plants related to wild parsnip in his Materia Medica. Charlemagne's Capitulare de Villis lists root vegetables among the crops required in royal gardens, and parsnip has often been associated with this tradition. Although individual plant identifications in medieval Latin texts can be debated, medieval European monastic herbals recommended various root vegetables during winter. When fresh greens were scarce, gardeners understood something. Modern food systems have largely forgotten parsnips actually improve in cold conditions. They do not merely survive winter, they transform. The biochemistry behind this transformation is one of the least discussed facts about parsnips. When roots are exposed to cold temperatures, enzymes can convert stored starch into sugars, mainly sucrose, glucose, and fructose. The same general process contributes to the sweetening of several root vegetables during cold storage. In parsnips, the change can be noticeable. A root harvested before frost can taste substantially less sweet than one left in cold soil, and harvested later, frost has literally changed its chemistry. Gardeners leaving parsnips in frozen soil were not necessarily being careless. They were allowing the plant to undergo a natural transformation. Parsnips also contain polyacetylines, bioactive compounds studied in laboratory research for possible anti-proliferative effects. These compounds are present in the peel and outer tissues of several Apiaceae vegetables. Although the health significance of consuming them has not been established in humans, traditional methods such as roasting the whole, unpeeled root can preserve these outer tissues. The skin becomes slightly charred and bitter, while the flesh beneath turns sweet and tender. Sow parsnip seeds in early spring in loose, deep soil. Shallow or rocky ground produces forked, stunted roots. Leave them in the ground through fall and winter. Then dig them after the third hard frost. What you pull from the January soil may taste As Silas Mercer's grandmother might have said, like candy. The frost does the work. You do the waiting. This is the monastic principle. Restated. Patience is the preparation. Number 3. Olive. The olive tree holds a unique position in biblical literature. In Noah's flood, the dove returns with an olive branch, signaling that the waters had receded and the earth was habitable again. In Exodus, olive oil is specified for consecrated preparations used in the tabernacle. It appears in Psalms, Proverbs, and the Sermon on the Mount as a symbol of peace and abundance. And in the Garden of Gethsemane, the olive was not incidental to these stories. It was an axis of Mediterranean civilization. The Caracas Samhita is not a reliable ancient source for olive oil. Specifically, sesame oil and other locally available oils played a much more prominent role in classical Ayurvedic medicine. While references to olive oil appear in later traditions and through cross-cultural exchange, the Benchao Gangmu also records substances and medicines from Western regions, but identifying a specific entry as olive oil requires caution. The primary bioactive compound in extra virgin olive oil is oleocanthal, a phenolic compound responsible in part for the peppery sensation in the throat. Researchers at the Monal Chemical Senses Center identified and named it in 2005, noting that its anti-inflammatory activity involves inhibition of COX enzymes in laboratory studies in a way that resembles one aspect of the action of ibuprofen. Its concentration varies greatly with olive variety. Harvest timing, storage, and processing. Early harvest. High-quality extra virgin olive oil often contains more phenolic compounds than oil made from fully ripe olives. Generations of Mediterranean observation revealed something simple. Some of the best olive oils have a sharp, peppery sensation in the throat. That pungency can indicate the presence of phenolic compounds, such as oleocanthal, although taste alone cannot reliably measure quality or oleocanthal concentration. Using genuine extra virgin olive oil as part of a balanced diet provides beneficial unsaturated fats and a range of bioactive compounds. There is no established daily dose of oleocanthal required for health. And high-quality olive oil can be used both unheated and in cooking. The ancient preparations that specified olive oil were not arbitrary. Generations of observation had already shown that different oils behave differently depending on how they were prepared. Modern research is now beginning to explain why. Number 2. Hyssop. Purge me with hyssop, and I shall be clean, writes the psalmist in Psalm 51. At Passover in Exodus, hyssop is specifically named as the plant used to apply blood to the doorposts, deliberately chosen, and at the crucifixion, John's Gospel describes a sponge soaked in vinegar being lifted to Jesus on a branch of hyssop, 3 pivotal moments in Hebrew and Christian scripture. And the same plant each time. Rabbinical commentators noticed a recurring pattern. Hyssop appeared at moments of purification, physical, ritual, and redemptive. The Talmud Tractate Nagayim, concerning skin conditions and purification rituals, names hyssop as part of the physical preparation for those returning to the community after illness. The rabbis were not speaking only symbolically. They were documenting a plant their tradition regarded as useful in purification practices. Hyssopus officinalis contains several bioactive compounds in its essential oil, including pinocamphone. Laboratory research has examined the antimicrobial and other biological activities of hyssop constituents. But claims of established antiviral treatment effects against diseases such as influenza or herpes simplex remain preliminary and should not be presented as proven medical treatment. Marrobine, a diterpene lactone, better known from horehound, is also found in some related plants and has been studied for expectorant properties. Psalm 51 reads differently when you know hyssop's traditional association with purification and respiratory preparations, although the biblical use is primarily ritual and symbolic, not a clinical prescription. But one detail is often overlooked: harvest timing matters enormously. Essential oil composition changes as hyssop develops. The precise concentration of pinocamphone depends on genetics, growing conditions, and harvest stage. So, a universal 40% decline should not be assumed. Harvest hyssop when the first flower buds appear. Dry it immediately in a single layer, away from direct sunlight. At room temperature, light and heat can accelerate essential oil loss. Properly dried and stored in an airtight glass container. Dried hyssop can retain its aroma and some volatile compounds for an extended period, although exact retention varies with storage conditions. To prepare hyssop tea, use hot water rather than boiling water and steep the dried herb briefly. Because hyssop essential oil contains potent compounds, concentrated preparations should not be treated as harmless simply because they are traditional. The finished tea is pleasantly bitter, slightly mentholated, with a warmth that settles in the chest. The psalmist asked to be purged with this plant. He was asking within a tradition where the plant carried a powerful meaning of purification. Number 1. Fermented grain. Number 1 is not a single plant. Number 1 is a process, and it may be one of the most consequential food technologies that the industrial system has thoroughly changed. Leavened bread appears throughout the Hebrew Bible. The Kamet's leavened bread of Exodus is so significant that its presence or absence defines an entire sacred season. The unleavened matzah of Passover is not simply flat bread, it is bread made in haste. Before fermentation could occur, the fact that fermentation had to be stopped tells us that fermented bread making was a familiar practice in the ancient world. The sourdough fermentation process, wild yeast, and lactobacillus and other lactic acid bacteria working together on grain for 12 to 24 hours does things to wheat that baking alone cannot accomplish. First, phytic acid, an anti-nutritional compound that can bind zinc, magnesium, and iron and reduce their absorption, can be degraded by phytase activity during fermentation. Wheat bread, fermented for a long period, can contain substantially less phytic acid than bread made rapidly with commercial yeast, although the exact reduction depends on flour, starter, fermentation time, and temperature. This means the minerals in a long-fermented sourdough loaf may be more bioavailable than those in some rapidly prepared breads. Second, gluten proteins can be partially broken down by proteases produced during fermentation. This helps explain why some people who experience discomfort from commercial bread may tolerate certain sourdough breads better, not because the gluten disappears, but because fermentation changes its structure and other components of the bread. A 2019 study in the journal Nutrients found that long-fermented sourdough produced a lower post-meal blood glucose response than rapidly fermented wheat bread, although responses vary among individuals and bread formulations. Third, fermentation produces organic acids and other metabolites, including compounds that can influence digestion and the gut microbiome. Some dietary fibers are also fermented by intestinal bacteria into short-chain fatty acids, including butyrate, which serves as an important fuel source for colon cells. Dietary fermentation is increasingly recognized as relevant to gastrointestinal health and the intestinal barrier. What did commercial baking change this process with fast-acting commercial yeast that can produce a rise in roughly 90 minutes instead of 12 hours? That shorter fermentation provides less time for certain enzymatic reactions. The result is bread that may look like traditional bread and taste like bread, but can be nutritionally different from a long-fermented loaf. The whole-grain sourdough loaf that fed the ancient world, the bread placed beside Elijah in the wilderness, associated with Daniel's dietary tradition, and found throughout civilizations, in this countdown, was fermented bread. It was often made from whole or less refined grain. It came from seed, saved by farmers, grown in soil, supported by crops, and leavened by wild cultures maintained, sometimes for generations, through a community's shared starter. The process was never only about wheat. It was about the entire living arrangement: saved seed, healthy soil, patient fermentation, and preserved culture working together in a system so integrated that changing one part could change the whole. Number 1 is understanding that integration. The supplement industry that opened this conversation was built on the idea that you can extract a compound from a plant, concentrate it in a capsule, and reproduce the benefit of the whole, traditionally prepared food. Decades of research increasingly suggest that this idea is incomplete. The anthocyanins in an elderberry capsule do not necessarily behave exactly like those in freshly prepared elderberry syrup. The oleocanthal in an olive oil soft gel is not equivalent to the complex mixture of compounds in cold-pressed extra virgin olive oil, and the beta-glucan in a fiber supplement does not carry the same food matrix as beta-glucan arriving naturally within the cell walls of a whole oat. The ancient practitioners who gave us every plant in this countdown were not primitive people stumbling towards solutions that modern science eventually perfected. They were sophisticated observers who understood, in the language available to them, that food is a system. Preparation is part of the medicine. The relationship between a plant and the person consuming it depends on dozens of variables that a capsule cannot contain. The question worth sitting with, and I'll leave you with, this is not which supplement to add to your cabinet. The question is what preparation method, growing practice, or patient ancient process you might be willing to restore. If this deep, historically grounded, look at how food actually works has been useful to you, share it with someone asking these same questions. Someone trying to understand why the old ways keep being rediscovered. Like and subscribe, because what's coming next goes even further into the plants that built civilizations and are still available to us today. In a backyard, a kitchen, or even a clay pot on a windowsill. Leave a comment and tell me which plant on this list grew somewhere in your family's history. What did your people grow that their children forgot? The plant most requested in the comments is the one I research next. These plants were never secret. They were simply common, so common they needed no advertisement, no aisle display, no influencer recommendation. Common as a dooryard, common as a fence line, common as a widow's root cellar in a Kentucky winter. The ancient world didn't know how lucky it was. Now you do.